A grad student comes home to his grandfather after a long day running trials in his lab.
Hey, Grandpa.
Hey, Sonny, how was school today?
Grandpa, I'm 33 and almost have my PhD.
He did not almost have his PhD.
Well, if you eat a live frog every morning, it's the worst thing that can happen to you all day.
Right. Well, anyway, if you really want to know, I've been utilizing DNA nucleotides to attach single-walled carbon nanotubes to gold electrodes in order to make nanoscale electronic devices such as transistors.
My God, Sonny, that was a whole lot of science-y mumbo-jumbo.
Okay, well, let me try a little simpler. We're trying to make devices that are really, really small.
Mm-hmm.
The problem is when they get that small, we can't put them together by ourselves. We need a little help, and so that's where the DNA comes in. So for example, let's say you wanted to take a carbon nanotube and make an electron device out of it.
Carbo nano, what now?
Carbon nanotubes. They're little tiny tubes made out of entirely carbon atoms. They're super strong, they have a lot of great properties, but that's not the point. The point is the DNA.
Deoxyribonucleic acid. I remember when that was invented.
Right. Well, anyway, here, look at this.
DNA is perfect for this application because it basically comes with its own assembly instructions. Each strand can only be made of a series of 4 different bases: adenine, cytosine, guanine, and thymine. These bases are shaped so they can only assemble one way. Adenine always matches with thymine, and cytosine always matches with guanine. This limitation is quite helpful in trying to make tiny devices. With some help, the pieces will naturally come together. We start by putting one DNA strand on the wire. Let's say we put a sequence of all adenine bases. Then, in order to make the device assemble correctly, we attach the complementary strand on the destination. In this case, the complementary strand is all thymine. Now, when the 2 strands meet, they will make the transistor in the way we want it to, all on its own. If we didn't attach complementary strands, the pieces would not come together.
Okay, but how does the DNA get attached to the tubes?
Well, they're still sort of figuring that out. Sometimes they wrap it around the tubes, other times they tag it on the end with other reactive bonding. Hopefully I can figure that out and finish my PhD soon. I think my thesis is going really well.
It was not going well.
Well, son, if you took that job at the Lawn Gnome Emporium, you might be mayor by now.
Right. Okay, Grandpa. Eat your Oreos and watch your Hawaii Five-O.